So we're going to do the problem that we saw in the previous video. So we have a sequence. First of all, this sequence is, as you can see, explicit. Why it's explicit? Because it's a relation between un and n, where n is the number of terms. Show that un is increasing and has an upper bound too. Because first of all, we're going to start by the variation. We're going to show it's increasing. The first step, I'm going to ask myself, is it explicit or recursive? So as we said, it's explicit, so we can do it directly. For the variation, we do un plus 1 minus un plus 1. Because I have un, I want un plus 1. For every add n, I add n plus 1, as you can see, minus un. So if you expand it, you're going to get this one. So same denominator, simple calculation, you're going to get 1 over n plus 2 over n plus 1. Because n is a positive integer, always bigger or equal to 0. So positive over positive is positive for all n. Hence un is an increasing sequence. I want to show it has an upper bound to. What does it mean, upper bound to? Upper bound to, it means all the terms of the sequence is less or equal to 2. This is upper bound. Okay, so all the terms of the sequence less than this term. So in other words, I want to show that un minus 2 must be less than 0. So we do it directly. Un, you have it, 2n plus 1 over n plus 1 minus 2. Same denominator, minus 2n minus 2, as you can see. Negative over positive less than 0. So in this case, 2 is an upper bound. So we have proved number 1. Let us go to number 2. Also, this is a sequence which is explicit. I want to show it's decreasing. Same story, un plus 1 minus un. You add for every n plus 1. So if you do same denominator, okay, you can see it here in details. You're going to get negative over positive less than 0. So un is decreasing. You want to show that it has a lower bound. What does it mean, a lower bound? Lower bound, it means all the terms of the sequence are after this number 3. Okay, so in other words, un bigger or equal to 3. So if you want to take the 3 to the other side, you want to show that un minus 3 bigger or equal to 0. Okay, so you start un minus 3. This is un minus 3, same denominator, positive over positive is positive. So we have proved that un has a lower bound. Okay, very simple. Show that the sequence un defined by this one, also explicit, is strictly increasing and have an upper bound. More practice problems, un plus 1 minus un, as we did up. You can check by this one. So you have positive over positive bigger than 0 increasing. It has an upper bound. All terms un minus 2, un less than or equal to 2, un minus 2, you must prove it's less than 0. Same story. Negative over positive, if you do it less than 0, so 2 is an upper bound. Explicit, you want to show it is decreasing, so we start un plus 1 minus un. Okay, same denominator, negative over positive. As you can see, these problems are very simple. It has a lower bound, all terms are bigger than 3, un minus 3 must be bigger than 0 if you do it positive over positive, so hence un has a lower bound 3. Now here, come in, it's explicit because relation between un and n. Calculate the first 4 terms of the sequence, what you can deduce concerning the variation, then study the variation. 2 power 0, if you do, first term is 0. If you replace u by 1, 2 plus 3 minus 1 is 4. You can see that the sequence is increasing. So you want to show to study the variation. You do un plus 1 minus un. You add for n plus 1 minus un. If you expand it, now here I want to tell you one thing. Let me do it step by step in these kind of problems. 2n plus 1, I'm going to keep it for the time being as 2n plus 1. You have plus 3n here, and minus here, don't forget you have the minus 3n cancel out, you have a plus 3, minus 1 plus 1 cancel out, the 3n and the 3n here, what remains? Plus 3 minus 2 power n. Now you have 2 power n plus 1, so I want to write the 2 power n plus 1 as 2 power n times 2 power 1, you know, you add the power n plus 1, plus 3 minus 2 power n. Now I want to take and I want to put 2n in factor here. So the first factor here will be 2 power 1, here the factor will be 1. Okay, so if you expand, 2 times 2n is 2n plus 1, as you can see, minus 2 power n. 2 minus 1 is positive, so 2 power n plus 3. So this is what, guys? This is positive. So it's increasing. 6. Here you have a recursive sequence. I cannot do it the same way as I did up. I have 2 steps. So I want to show that recursively that un is bigger than minus 2, that minus 2 is a lower bound. So here in this case, I will say, before we used to say un directly plus 2, I use the given and I want to prove bigger than 0. This is an explicit. In recursive, no, you check it for the first terms. So you have u0 is 1. So u0, which is 1, is bigger than minus 2. Okay, you can check for another term, u1. If you want to do u1, you're taking here n to be 0, is half u0 minus 1. But since u0 is 1, so it's 0. 0 is bigger than minus 2. Enough. You are obliged to do these. Then you say, suppose un bigger than minus 2 or un plus 2 bigger than 0. I want to show it for the next term, un plus 1 plus 2 bigger than 0. Why I want to do this one? Here I cannot find any term I want. If I want to find any term, I need to find all the terms before. So that's why, if I know that u0 bigger than minus 2 and u1, for example, bigger than minus 2, if I prove this one, if un plus 2 bigger than 0, the terms after should be bigger than 0, like here. Since u0 is bigger than minus 2, 100% the term using this loop, this is called loop, u1 must be bigger than minus 2. Because u1 is bigger than minus 2, 100% u3 must be bigger than minus 2. Since u3 bigger than minus 2, for example, u4 must be bigger than minus 2, and so on. So this is called a recursive proof. Always when it's recursive, you need to use this proof. In explicit, we used to do only this one, un plus 2, use the given, you get the answer. Here, no. The things that we used to do in explicit will be the supposition. Suppose un plus 2 bigger than 0, I want to show for the term after. So how do I start? I start by the first part of the conclusion. Okay, I use my given. This is the given. un plus 1 plus 2. un plus 1 is half un minus 1 plus 2. So I expand, it's half un plus 3 over 2. So I can put half in factor, so it's un plus 3. However, here I have un plus 2, I need to use the supposition. un plus 3 can be written as un plus 2 plus 1. If this is positive here, plus positive is positive, times positive is positive. So from supposition, un is bigger than minus 2. So that's why, no, this term is bigger than 0, so I have proved what I want. Here the same thing, calculate u1, u2, u3, show recursively that this sequence is strictly increasing. This is a recursive. So for u1, you can see it's 2, u1, u0 is 1, u2 you're taking n to be 0, 3 u0 minus 1, so 3 minus 1 is 2. After u1 you have u2, you're taking n to be 1, so 3u1 minus 1, since u1 is 2, 3 times 2, 6 minus 1 is 5, and so on. So as you can see, it's increasing. Since I have the first term and I know it's increasing, in explicit we used to say un plus 1 minus un, and we start to get bigger than 0. Here, no. This will be the supposition. I want to show it from the next term. The next term I add I mean for every n plus 1. So I want to show it to un plus 2 minus un plus 1. So I start by the first part of the conclusion. I use the given here. I have un plus 2. I have un plus 2. So un plus 2 is 3 un plus 1 minus 1. Minus un plus 1 is a 3 un minus 1. Minus 1 cancel out. I can put a 3 in factor. So un plus 1 minus un is bigger than 0 from supposition, hence un is increasing. The last problem, also recursive. So show that un has a lower bound, minus 6. You know that u0 is bigger than minus 6. If you do u1, so it's u0, so 3 minus 12 is minus 9 over 3 is minus 3, and minus 3 is bigger than minus 6. So for the first term, it's 100% true. So I say, suppose un bigger than minus 6, okay? Un, because minus 6 must be lower bound. So all terms of the sequence bigger than minus 6, I need to show that un plus 1, the term after bigger than minus 6. So I take both the minus 6 to the other side. So this is the supposition, this is the proof. So I start from the first part of the conclusion. Also, always I use my given, as you can see here, plus 6, same denominator. You have un plus 6. I know from supposition bigger than 0. So hence un is bigger than minus 6. Decreasing. You can see that u0 was 3. u1 is minus 3. As you can see, it means it's decreasing. I say, suppose un plus 1 minus un less than 0. I need to show it for un plus 2 minus un plus 1. So I start from the first part of the conclusion. I use the given as I did up. So here un plus 1 minus 12 minus un plus 12. 12 and 12 cancel out. I know from supposition this is less than 0, so it means it's decreasing. So that's why I hope that you got the variation and the explicit and recursive. Prepare well and see you.